So in this topic, we will discuss the particle accelerators, how we can probe a matter, investigate a matter, and particles accelerators. Mainly particle accelerators are also used for purpose of probing matter. What happened when we collide the particle at high speeds? So this will result in a formation of the massive particle. So first one, it's a Rutherford experiment. It's a Rutherford gold foil or metal foil experiment. What he did, a Rutherford uses high energetic beam of alpha particle, and he target this by a and he focused this beam on a metal foil or a gold foil. And what he observed most of the alpha particles are able to pass through. This observation, most of them are able to pass through. Few of them deflected, like changes or deviate from the path, and few of them bounce back or reflected back. So what is the conclusion of his experiment? What he concluded from his observation? So observation, he observed most of the alpha particles went straight or passed through. Few of them deflected, and some of the alpha particle deflected through a large angle, and few of the alpha particle came straight back towards the source. So what is the observation? The first observation conclusion, that most part of atom is empty. That's why most of the alpha particles are able to penetrate or pass through. Some of the alpha particle deviated through a large angle because the nucleus and alpha particle have the identical charge, so like charges repel. That's why alpha particle deviate from the path. And some of them bounce back. Why they bounce back? Because there's a matter in the nucleus. That's why some of the alpha particles are able to bounce back. So if they are able to pass through, majority of them are able to pass through, shows major portion is empty. Few of them deflected, shows that there's a repulsion or attraction or deviation from the nucleus. That's why attraction from the electron and repulsion from the nucleus, but the repulsion is stronger. That's why they deviate from their path. And few of them bounce back. Why it bounce back? Because, or what it shows that there is a mass or a matter. That's the reason these alpha particles bounce back. How we can produce a beam of electron? There are two ways to produce a beam of electron. One is called thermionic emission, another one is photoelectric. Photoelectric effect you took in AS, that what happened in photoelectric effect? When the light in the form of photon or particle falls on the metal surface, if this energy of a photon is enough or more than or equal to the work function minimum possible energy to remove electron, so this electron will come out. And when a photon emitting out electron, we call that as photoelectric effect. So this is one way of removing electron. There's also another way of removing electron from the metal, that's called thermionic emission. So thermionic emission, basically we heat the metal, so electron have sufficient energy, so they are coming out from the metal surface due to the heat, and they are accelerated by using, this is how we remove electron. But how to accelerate them? We use an electric field to accelerate these electrons. So we can say the electrical energy is equals to kinetic energy. Electrical energy is given by E into V, and kinetic energy is half mv square. So using this formula, we can find the speed at which the electron will move in the region for a specific voltage. Because the things which are constant, the mass of an electron is constant because it's not moving close to speed of a light. E is a charge which is also constant. So the voltage will decide the speed at which the electron will move. Then what is the electron probe? Electron probe means if we are using electron to identify or to examine the structure of a material, we call that as an electron probe. And this electron probe uses a concept of wave particle duality, that electron is a particle but it can also behave like a wave. And according to de Broglie's, the formula which relate the momentum or the mass and velocity of electron with the wavelength, lambda is equals to h over p, where h is a Planck's constant. So if the wavelength which is associated with the electron matches with the gap, then what we will observe? We'll observe a maximum diffraction. So a diffraction pattern will be observed. So normally what happened, like to investigate, to I'll find the structure or to probe the structure of the ionic compounds, we can use electron diffraction. So we pass electron, but this electron wavelength associated with this electron is matching. If it matches with the distance, the gap between the ions, so what we'll observe? We'll observe diffraction will occur. So electron is a particle, but diffraction occur, which shows it is not acting like a particle. Actually, it is acting like a wave. Is it clear? So if you want to increase the wavelength, momentum is a product of mass. If we want to increase the wavelength, we should decrease the momentum. Or if we want to decrease the wavelength, because if we want to decrease this lambda, we should increase the momentum. And how we can increase the momentum? By increasing the speed. And how we can increase the speed? So for this purpose, we are using electric field. So we have the formula half mv square is equals to EV. So we apply more voltage so that electron will have higher speed, greater momentum, shorter wavelength. Shorter wavelength, it matches with the gap size, so maximum diffraction occur. So we can use this probe to have a more detailed image. Is it clear how electron probe is used to study the structure of the matter? Any doubt in this part? Now, to produce massive particles, we collide the maximum diffraction means when the wavelength is equal to gap size. And because the gap is so small, the between the ions, the gap is so small, so we want to decrease the wavelength. So if we want to decrease the wavelength, we should increase the momentum. How to increase the momentum? Mass is constant, so we increase the speed. And how we can increase the speed? We use electric field to accelerate this electron. So for this accelerating electron, we increase the voltage, so it will have higher speed. So if we want to probe a matter or we want to produce new particles, massive particle, so we should collide the two particles with each other and in opposite direction. Why opposite direction? As we discussed now, because when we are colliding them in opposite direction, initial momentum is zero for identical particles, so final will also be zero. So energy will not be used as a kinetic for the particle, like the momentum, to conserve the momentum. As the initial is zero, so final will be zero. So most of the energy is used to create the particles. But how we can increase the speed of these particles? So for this purpose, we use particle accelerator. the first particle accelerator, which is also known as line AC or linear particle accelerator. This linear particle accelerator is using cylindrical tubes, hollow cylindrical tube with alternating voltage is applied. AC is applied. So positive and negative. So what happened? For example, if you want to accelerate this electron, so first the electron will come out. So as this electron will come out, one end will receive the positive terminal, another one is negative. So when electron experiences attraction from a positive terminal, it is accelerated. But when electron is within the tube, there is no electric field because the voltage is applied outside. It's a hollow tube. So as we discussed, the hollow cylinder, hollow spheres, within the sphere, within the cylinder, there is no potential. All the charge is at the surface. So if electron is within the cylinder, there is no potential or voltage. So electron is not accelerated. In that case, the electron will move with a constant speed. So first what happened? A positive potential, example on the left, and negative on right, plus minus. Because it's an AC, so the terminal will change. So electron is accelerated. But when electron is traveling within the cylinder, the terminal changes because it's an AC, so the terminal changes. But the speed of electron does not change within the tube. As the tube, within the tube, there is no electric field, so there is no acceleration for this electron. So when the electron is within the tube, the terminal of the, because it's an AC supply, so this side will be negative, one end will be negative, other one will be positive. But this will not affect the motion of the electron. Why it will not affect the motion of electron? Because within the tube there is no electric field, resultant electric field. That's why electron is not accelerated. The moment electron reach the other end of a tube, again the terminal changes. So now the positive is on the right and positive is on the left and negative on the right. So electron again it is accelerated. So this part again it is accelerated. But when it moves within the tube, there is no acceleration, no change in speed. And each tube, the electron will take the same time. Even though you can see here the length is shorter, length is increasing. But electron will take same time to cross each tube so that it will receive the same potential every time when it comes out from the tube. So accelerated, then move with a constant speed. Accelerated, move with a constant speed. Accelerated, so within the tube it is constant speed, but outside the tube it is accelerating. So every tube electron will take the same time. Why? Because here distance is shorter, it was moving with a slow speed. Here distance is more, but it is accelerated, so higher speed. Here also distance increase, speed is also increasing, but the ratio of the distance to speed remain constant. So if electron was taking example 2 seconds to cross tube A, it will take same 2 seconds to cross tube B. It will take same 2 seconds to cross tube C and same 2 seconds to cross tube D. But what will be the difference for these each tube? The speed when it enter tube A will be different from tube B, tube C and tube D. What is the reason why whenever electron moves through the tube, it should take the same time? Reason for that, otherwise when the potential changes, say if electron is moving and it reached this point, so we should have a positive potential here so that electron is accelerated. When next time it will come at this point, it should receive a positive potential. But if it is not taking the same time, it might not receive the same potential. Maybe when electron come out from tube A, it might receive a negative potential. So it will not accelerate, it will decelerate. That's why every tube, each tube, when it is passing through each tube, it should take a same time. So when the terminal changes, electron will always experience the positive potential and accelerated instead of decelerated. Is it clear, this part? So this is also known as line. So linear accelerator consists of the tubes equally spaced with an increasing length and a high frequency AC supplies there. So AC supply means first this is positive, positive, negative, positive, negative, positive, negative. So when electron is coming out, it is accelerated. But once electron is within the tube, it is moving through the tube, the term, because it's an AC supply, it changes the terminal. Then what happens? This will be negative, positive, negative, positive, negative, positive, negative, positive. Then when the electron reaches this point outside, again the AC terminal changes. So as the terminal change, again positive, negative, positive, negative. So due to this positive, negative, the electron will accelerate from tube A to tube B. When it reaches this tube, again the terminal changes. So this will be negative, positive, negative, positive. So it does not affect the motion. When it reaches, because it's taking the same time, so when it reaches the end of the other end of tube B, again the terminal changes and the electron will accelerate. Is it clear, this linear particle accelerator? And until we have electron at a certain speed, so we can collide with another particle and produce more particles. Is it clear, the working of the linear particle accelerator or LINAC? So you can see the change in velocity, acceleration, it's like accelerating, like a constant velocity is there, accelerating, then a constant. For this part, actually, according to theory, this should be exactly horizontal, the speed should not change, but there is a slight change in the speed. That's why this is given, this graph is given in terms of practical. But if I say the speeds of particle, so when it is outside the tube, it accelerates. When it enters the tube, it moves with a constant speed. So it's like this. Theory says, theoretically it's like this, but practically speed changes, slightly changes, but according to theory, it is constant but higher speed. Then for the second part, when it enters the other, means come out from the tube, again there's a voltage that will accelerate, so it will have a higher acceleration or greater acceleration, and speed increases. When it enters the tube, it will be constant. So the next will continue the other accelerator. There is another accelerator which is cyclotron and synchrotron, that we'll discuss in the next class. Any question or doubt related to this part, linear particle accelerator and probing the matter? Any doubt? So I'll end the session and share the recording with you.